Hello viewers, in today's class we are going to discuss one important problem from definite integration, right? And here we have to solve this integral in which the greatest integer function of square root of x is involved, right? So this problem is going to be a very conceptual problem, and this is quite useful for the beginners who are practicing definite integrals of greatest integer function, right? So let us start, and let us first call this integral as I, right? So here what we will do, we can solve this problem by two methods, right? The first one is the method of substitution, and the second one is the method of inequalities, right? So both the methods are easy and useful, but here we'll prefer this problem by solving this problem by using the method of inequalities, right? So let us start. So here we see that the lower limit is x is equal to 1, right? And the upper limit is x is equal to 5, right? So here we see that the limit varies from 1 to 5, right? So x belongs to this interval, that is x varies from 1 to 5, and let us find the interval in which the square root of x varies, right? So see, when x is equal to 1, then the square root of x is equal to square root of 1, that is equal to 1, right? And when x is 5, then the square root of x is equal to square root of 5, and here it is not a perfect square, so we'll take the approximate value of square root of 5, so that is approximately 2.23, right? So we see that when x varies from 1 to 5, then square root of x, it varies from 1 to 2.23, right? And we can also write it as 1 to square root of 5, right? Okay, now here let us write f of x is equal to square root of x, and here we have the greatest integer of x, right? So here we are taking only this part as the function f of x, which is the greatest integer of square root of x. So here what we will do, we'll try to express this function f of x as a piecewise function, right? So what we will do, see, here the greatest integer of square root of x, it takes the value of 1, right? When the square root of x, it lies between 1 and 2, right? And the greatest integer of square root of x, it takes the value 2 when square root of x, it lies between 2 and square root of 5, right? So why we have written this one, see, here we have square root of x belonging to this interval, that is 1 to square root of 5. So here we can write 1, and here we can write square root of 5, which is approximately equal to 2.23, right? So 2.23 is close to 2, so here we can take 2, right? So see, here these numbers are represented corresponding to square root of x. So see, square root of x, when it lies between 1 and 2, see, here we have 1 and here we have 2, right? So when square root of x, it lies between 1 and 2, then the greatest integer of square root of x is equal to 1, right? And when square root of x, it lies between 2 and square root of 5, 2 and square root of 5, then the greatest integer of square root of x has the value 2 by the definition of greatest integer function, right? So here what we have done, see, when x is 1, then square root of x is 1. When x is 5, square root of x is 2.23, right? So for square root of x, it varies from 1 to 2.23, right? So square root of x, it varies from 1 to square root of 5, right? And between 1 and square root of 5, we have the integer 2, right? So what we have done, we have split this function square root of x into two parts, right? So the first one is from 1 to 2, which is here, that is 1 to 2, and the second one is from 2 to square root of 5, right? So the greatest integer of square root of x, it has the value 1 when square root of x, it lies between 1 and 2, and greatest integer of square root of x is equal to 2 when square root of x, it lies between 2 and square root of 5, right? So now what we will do, we'll solve these two inequalities, right? So the first one is 1 less than or equal to square root of x. Here we have 2, and now if we square throughout, then we'll get 1 less than or equal to x, and here we have 2 square, that is 4, right? So this inequality is equivalent to this one, right? And now let us take the second one. So here we have 2 less than or equal to square root of x, and here we have less than root 5. Now if we square throughout, then 2 square is 4, and here we have root x square is x, and here we have the square of root 5 is 5, right? So now this inequality is equivalent to 4 less than or equal to x, and here we have 5, right? So now we can redefine f of x like this. See, f of x is greatest integer of square root of x. So now we can write, here we have 1. So greatest integer of square root of x takes the value 1 when x, it lies between 1 and 4, right? And greatest integer of root x, it takes the value 2 when x lies between 4 and 5, right? And see, in the original integral we have to integrate from 1 to 5, and see, here the starting point is 1 and here the end point is 5, right? So we have to integrate from 1 to 5. So the intermediate point between 1 and 5 is 4, right? So if we now plot these points here, this is 1, this is say 5, and between 1 and 5 we have 4. So this representation is corresponding to x. So now x varies from first from 1 to 4, and then it varies from 4 to 5, right? So this implies that we have to split this integral as a sum of two integrals, that is I1 and I2. So I1, it goes from 1 to 4, and I2, it goes from 4 to 5, right? And here we have square root of x, and the greatest integer of root x is represented by f of x. So here we have f of x, this is dx, and here we have root x, then we have f of x, and here we have dx, right? So now see, we can write I is equal to 1 to 4, and here we have square root of x, and see, when x varies from 1 to 4, that is 1 to 4, f of x takes the value 1. So here for f of x we can now write 1, and now here we have 4 to 5. Here we have 4 to 5, and here this is root x, and f of x takes the value 2 when x goes from 4 to 5, right? So here for f of x we can write 2. So now we have these two simple integrals to evaluate. So now to evaluate these two integrals, we can make use of this result from indefinite integrals, that is integral of x raised to n is x raised to n plus 1 over n plus 1 provided n is not equal to minus 1, right? So now we can write I is equal to, here we have square root of x, which can be written as x raised to half dx, and here we can take 2 outside the integral being a constant, so we have x raised to half dx, right? So now the integral of x raised to half is x raised to half plus 1. Here we have half plus 1, limits are from 1 to 4, and here we have 2 times x raised to half plus 1. Here also we have half plus 1, and limits are from 4 to 5, right? So now we can simplify it. So this is 3 over 2, so we can write it like this, 2 over 3, and here we have x, and here we have 3 over 2, limits are from 1 to 4. Here we have 2 times 2 over 3, and here we have x raised to 3 over 2, limits are from 4 to 5, right? So now we can take the limits here, and we'll take the difference. So here we have 4 raised to 3 over 2 minus 1 raised to 3 over 2. Here we have 4, 2 to the 4, 4 over 3. Here we have 5 raised to 3 over 2 minus 4 raised to 3 over 2, right? So now let us simplify it. So we have I is equal to, this is 2 over 3, and 4 raised to 3 over 2 can be written as 4 cube raised to half. This is 64 raised to half, that is 8, right? So here we have 8, 1 raised to 3 over 2 is minus 1, so this is 1, and then we have 4 over 3, and 5 raised to 3 over 2 can be written as 5 root 5, and we have here 5 root 5 minus this is 4 raised to 3 over 2, that is 8, right? So now we can simplify it. So this is 7 to the 14 over 3 plus this is 20 over 3 root 5, this is 32 over 3, right? So now 14 minus 32 is minus 18, so this is 20 root 5 over 3 minus 18 over 3, and we can write it like this. This is 3, the LCM is 3, so we have 20 root 5 minus 18, right? So the value of this integral is equal to 20 times square root of 5 minus 18 and divided by 3, right? So viewers, this is how we can solve these type of integrals involving greatest integer function.